This trig equation looks pretty simple, but it's deceptive. If you thought that one to the fourth power, the quartic, was pretty tough, that was only because you hadn't seen or tried this one yet. Just saying. Notice we have secant and tangent in here. It's a mixture. This one's going to involve a couple of strategies. We can't do a substitution to turn one into another one, so let's turn them all into sines and cosines. Secant is 1 over cosine x. Tangent, of course, sine x over cosine x. They just happen to both have a common denominator cosine, so I'm just going to add up the numerators. 1 plus sine x over cosine x equals 1. And just multiply that cosine over to the right hand side. 1 plus sine x equals cosine x. It's not quite that much simpler than that, but at least it has just sines and cosines. This is not the only way that you could do this equation, but this is the way I chose to anyway. So just like on that previous one, when you just have a sine, cosine, nothing is squared, let's make them squared. Square both sides. When we square both sides, we have to be careful if we introduce some extraneous solutions. Left side, we're just squaring a binomial, so the pattern here is 1 plus 2 sine x plus sine squared x. If you don't remember that little pattern here, you could just write 1 plus sine x down twice and then FOIL it out, and probably waste an extra minute anyway. And over here I have cosine squared x. Since the left side has both sine squared and sine, I'm going to take this cosine squared, use the Pythagorean identity, and substitute 1 minus sine squared in its place. Copy down the left hand side. That's a 2. Okay. There's 1's on both sides, so we can subtract them. So they cancel out. Continue way up here. Let's go ahead and add the sine squared over here to the left hand side, so we have 2 of them. 2 sine squared x. We have 2 regular sine x equals 0 now. They both have a factor of 2, so let's just divide both sides by 2 so we don't have to deal with it. By 2's, so sine squared x plus sine x equals 0. They both have a common factor of sine, so we'll factor that out. What's left behind is a sine x plus 1. Set them both equal to 0. Sine x equals 0 on one side, and on the other, sine x plus 1 equals 0. On the left, where is sine equal to 0? Where's that y-coordinate equal to 0? Right here at 0, and over here at pi, over here at 2 pi. I'm just going to leave it like this, not worry about the general solution just yet. We'll have to check these back in the equation, see if they work. On the right hand side, subtract the 1 over, so sine x equals -1. Look on the unit circle, let's figure out where the heck is sine equal to -1. Y-coordinate is -1 at 3 pi over 2. So let's test them, let's see which ones work. So let's first take 0. If I plug 0 in here, secant of 0, maybe you don't know offhand secant of 0, so let's look at this part instead. 1 over cosine of 0. Cosine of 0 is 1. 1 over 1 is just 1. Tangent, what is tangent of 0? Tangent of 0 is 0 because sine of 0 is 0 on the top. So that's 0. 1 plus 0 is equal to 1. That checks out. That means also all of the coterminal angles with 0 will check out. If we try pi, 1 over cosine of pi is actually -1, because over here x-coordinate is -1. But the tangent is still 0. -1 plus 0 is not 1. So this one does not work. So here we just have the solution, all the multiples of 2 pi. So 2 pi n or 2 n pi, however you want to state that. Over here on the right hand side, 3 pi over 2, if I stick 3 pi over 2 in here, 1 over cosine of 3 pi over 2, this is where cosine is equal to 0, so this would be undefined. Who cares what this one is? Undefined plus anything is not equal to 1, so all of this is garbage. Here's your only answer, the end.